Okay. Another week passes by. Before we start, is there any questions that anyone has regarding anything we discussed last lecture about JavaScript basics, or anything that you've encountered in the labs that you might have questions about, whether it be about Bootstrap or HTML or CSS? Or are we pretty much so far, based off the work you've done, on relatively firm ground? I should be recording at this point. Yeah, it shows the recording icon. So last class, we really ran through the basics of JavaScript. We did about half of, I guess, 1583 in about an hour and 15 minutes or so. So in today's lecture, I want to start going over the data structures that are available in JavaScript. I think I'm going to break data structures down across a lecture and a half. So I think today's goal is going to be to, let me go to their overview. So in terms of our data structures, in week 4, lecture 6 now, we're going to talk about arrays. And with arrays, we can talk about stacks and queues. We can talk about sets. We talk about maps. And then iterator functions that can be declared on arrays, sets, or maps. Then we could talk about the various traversal methods that are built into the arrays class or the arrays object. And we'll talk about a distinction between first order functions and high order functions when we look at these traversal methods. And then we'll look at the spread operator and a concept that's called destructuring. And so after covering these concepts, we'll then move on to objects and object-oriented programming with JavaScript. So it's my intent to, I think we'll cover all of arrays, stacks and queues, and sets over this lecture. And then I'll likely reserve maps, iterators, the traversal methods, and the spread operator for next lecture, and hopefully introduce the concepts of object-oriented programming at the end of next semester too. I'm trying to get through all of the foundational JavaScript so that we can start learning how to use JavaScript to affect the in-memory HTML elements in the browser, which is what we refer to as the document object model. So we're slowly going to progress to that point, but I'm really taking a hardened approach to teach you JavaScript the same way that you learn Java, as it is a pure programming language reminiscent to Java. So we can do all of our similar application logic in JavaScript as you might have learned to do in Java. But JavaScript gives us access to the browser, which allows us to produce beautiful visualizations very quickly, very rapidly, and it allows us a portable platform to run on any device. Okay. So with that said, let's move on to arrays. Okay, so with arrays, I want to cover what are arrays, how do we define arrays in JavaScript, how might we instantiate an array in JavaScript, when I say properties of arrays, what I really mean to say there are what are its fields, or what are its attributes, or essentially what are its instance variables. Then we'll take a look at the assessor, the accessor methods, or the getters in arrays, the mutators in arrays, and then we'll look at ways to transform arrays from one type of data into strings, or how we can transform arrays into different arrays. So we'll look at some abilities to process on arrays. Okay, so effectively, in JavaScript, an array is an index collection. So that means it's an ordered list. So it's very similar to the way you would think of an array in Java. However, there is some nuanced differences. Just like in Java, arrays are fundamentally objects. So if I do a type of on an array, it'll give me back the object type. And so it's essentially a special type of object that has built-in methods that allow you to traverse its elements or items and be able to set or get its values back. Okay. Now, arrays are going to differ a little bit from Java in the fact that the types of the elements are not fixed. So whereas in Java, you had to use the same data type for every element of the array, since JavaScript is a loosely typed language, we can actually use any type of data within an array. So here's an example of me just quickly declaring an array. I just let this be part of the window variable, but note that I should have done const, but I didn't want to eat up my horizontal real estate, so I just did I just did an assignment here. But you can see I'm initializing an array, and I'm using a comma separated list, and each one of these elements, each one of these items inside this array is a different data type. I have a string, I have a number, I have a Boolean value, and then I have a object. And you'll see it does resolve to give me a 4-element array, all with each of those elements. So this is one distinction between JavaScript and Java, where you can literally put any type of data into an array, and it's valid. Another thing that might be different in JavaScript is arrays are not guaranteed to be dense. Now, they're not necessarily guaranteed to be dense in Java either, but they are guaranteed to be a predefined size. So in Java, when you first create an array, you declare what size you want it to be. Arrays in JavaScript work more like an array list in Java. So when you create an array initially, it would be empty. It would not have any. It would not have any elements in it, but it could potentially grow or shrink as you add elements to it. Now, one interesting thing about what I mean by it's not guaranteed to be dense is look at these actions that I'm doing here. I'm creating an array. So I'm just creating a variable R. I'm assigning it initializer list. We'll talk about that more when we get to the constructors of array. So I'm just creating an empty array here. I will then index. So we index into array. Again, we'll see this in a little bit, but I'm going to try to index into the array at item or index 100. So that doesn't exist, but I can do that in JavaScript. I can do an assignment at index 100 and assign that value 0. And so I get back a non-error result from the console. And so when I go and inspect the state of my array variable, it shows that I actually have 101 elements, 101 indices, assignable indices now, where the first 100 are empty, or from 0 to 99 is empty, and at index 100 is the value of 0. So you can see being able to go ahead and use any number to index in and assign a value made this array jump from having no elements, no indices to 101 indices. And so that's what we mean that there's no guarantee to be dense. There's no guarantee that it's going to be restricted to a particular size. Okay, so let's talk about how we can instantiate an array. We can instantiate using a list initializer. So this is not too dissimilar to how we can use an initializer list in Java, right? So the list initializer is just the square brackets. And then we can either have nothing in those square brackets, or we can have values that are separated or delimited by a comma. And either way, we can then assign that to a variable, and that will create an array variable for us. And again, you'll see here, if I do this line, it will resolve into an empty array. If I do this line here, it resolves into an array that has 2 elements or 2 items in there. So it's got a length of 2. I can also use a constructor to instantiate an array. So we use constructors in JavaScript, very similar to how they're used in Java. So here I'm going to assign to my R variable a new array instance. And so I use the new keyword in conjunction with a constructor. So it's going to be the name of essentially the class, capital letter, and it's a method call. And any parameters you might need to pass into there will then get passed into the constructor. So again, you'll see that our syntax for JavaScript is going to be very similar to what you're already used to. Okay, let's suppose we want to instantiate an array with multiple parameters. I can do that. I can give a comma-separated list. Suppose I have the string A, comma, string B, and I pass that to my array constructor. This will resolve to create an array that has these two elements. So that's an alternate way I can go ahead and create an array. Let's say I have a single parameter. I can go ahead and invoke the constructor and pass that single variable, and it will create an array with that one element. So you might be wondering, why am I spending all this time showing that you can have no parameters, or you can have multiple parameters, or you can have a single parameter? Because it's super, super important that if you use the array constructor, you do understand this one nuanced thing that is different. If you use a single integer inside of the array constructor, it will not create an array with the single element of 10. Instead, numbers, a single number that is passed into the array constructor is perceived to be, like it would be in Java, the size of the array when you initialize it. So notice if I pass just the number 10 as a singular parameter into the constructor, it will then create an array with 10 empty indices, with 10 empty cells that values could be assigned into. So this is just one thing you should be aware of if you go ahead and are generating arrays, that this is the behavior for a single int. So understand it's not going to do like what it does with a string. Okay, let's talk about some of the properties that arrays have. So the arrays only have one property. It's their length property. So if I create an array, and I'll just use the list initializer here, and I'll pass in 3 different elements, 3 different items separated by commas. I'll assign it to this variable r, short for array, and then I'll go ahead and request the length. Now, since this is a property, since this is a field, since this is a variable, I don't use the parentheses, right? It's not a method call. It's actually accessing a data attribute assigned to this particular instance. So since this array has 3 elements, it will report back 3. Now, this is, again, where the idea of these data fields is going to be a little bit different than Java. The length of a JavaScript array is not fixed. So again, it's very much like an array list. It can grow, it can shrink, but it's also, and this is the crazy thing, it can be overridden. So what do I mean by that? Suppose that I create this array that I just showed right here, ABC, and I ask it, okay, what is your length? And it says, oh, my length is 3. I can actually overwrite the value of length and say, no, your length is 0. And if I do that, it's actually a way that I can clear all the elements out of that array. If I then go and inspect that array variable afterwards, it will report that it has 0 elements. And that's because the array is at length 0 at that point. I could also reassign it with a really big length, and then it'll say it has a lot of empty elements. So be aware that you can actually overwrite the value of length in an array, which is not the case for some of the other data types. They actually create something like a clear method to be able to clear out the data in the other data structures. So let's talk about the our getters inside of an array. We can get data out of an array very much like you would anticipate in Java. We use these square brackets, and in between the square brackets, we use an indexer. So I have my variable name, or my label, my variable name R, or short for array, to hold this 3-element array. I'll go and dereference at index 0 the value of A. I'll go and dereference at index 1 the value of B, and I can go ahead and dereference at index 2 the value of C. Again, arrays, just like in Java, or essentially ordered lists. So I use the index number to dereference the value at that particular order number. Now, what's different about Java is that JavaScript will allow me to use any index number that I want. It might just not return back a value. So in this 3-element array, the only values that I have, the only indexers that I have that correspond to values is 0, 1, and 2. I could use 3, but it's going to return back an undefined because there's nothing defined in that index value. But it's not going to give me an error. It's the same thing. I can actually pass in a negative value, and it's going to give me back a not a value or undefined, but it's not going to give me an error. In fact, this is going to get really wonky in just a moment, and I just want you to be aware of some things about how we can set values in an array. Okay, so let's talk about our mutators. We can go ahead and set data into the array very similar to how we do it in Java. So this is small. Forgive me, I tried to put a lot of different examples inside of this slide. So I'm going to walk through line by line here. So I'm going to go ahead and create an array, R, with these 3 elements. And then at R, at index 1, I'm going to overwrite it with the string X. And it's going to resolve. And so, okay, X got delivered into the, or overridden into that array cell. So I'm going to inspect the array afterwards. And where the B was, because that's index 1, is now an X. So notice I can index into an array and overwrite a value in a particular cell the same way I would in Java. Now, again, we saw this previously. I originally had an array that only had 3 elements. So the highest index value was 2. But if I wanted to, I could use index 100 and go ahead and assign Q there. So the string of Q. So that resolves without error. And if I inspect the array right inside my console, it's going to show that at index 0, I have A. At index 1, I now have X. So I did the overwrite. At index 2, I have the C. Then I have 97 empty cells. And then I have a Q. And so that's how that's going to resolve. So you can at any time use whatever index value you want, provided it's positive, and it will be part of the array elements. Now I said as long as it's positive. Now this is where again you have to be aware of how objects, how arrays are objects, and in JavaScript you can assign new values, new attributes to objects at any time. And so arrays are like decorated objects where the setters and getters are defined to use the square brackets. So I can actually pass in, like I can use the index value of -1. That's fine. I'm going to assign this question mark string and see what happens if I try to assign at the index of -1 this question mark. And so then I inspect my array. Now notice the size of my array. So before I did this assignment, the size of my array, the number of elements was 101, right? A, X, C, 97 empty cells, and then Q. This looks like it worked. And in fact, it did work in one kind of way. But when I go ahead and inspect the state of my array, it's still at 101 elements. It shows A, X, C, empty, 97 spaces, Q, but then it's showing the -1, and associated with it is a question mark. And so that seems super interesting, right? So I'm going to go and say, well, can I use that -1 as an indexer and get that value? And sure enough, I can. I'm like, that's really weird, right? So let me see if I can do something that's not just not a positive number. Let's see if I can do something like a string. So I'm going to pass a string into my indexer here and assign like an exclamation mark. This seems to resolve. Now, when I inspect, I'm still at 101 elements in my array, but it also shows, well, at this value, at this key A, I actually have an exclamation mark. And so I'm like, is this array an array? Let me check. So I'll check, is R an instance of an array? And that's true. But this is the big thing. The only real elements in this array are the ones that have positive index numbers or positive numbers, positive integer numbers. So I can technically do assignment into an array object that use strings as a key or use negative numbers as a key. But what I'm doing is I'm adding new array variables that are not part of the indexing. It's not part of the ordered list of elements. It's now an attribute that would be similar to size, right? It's part of the instance of array, but it's autonomous and separate from the collection that it maintains. Does that make sense? I know that's kind of nuanced and it's kind of weird to see. So I just want to illustrate that this is possible, but it's not doing the behavior you might expect it to. Okay, other than using indexing to go ahead and assign elements into an array, you can also use an array method called fill. So the indexing approach allows you to set one value at a time in your array. The fill method allows you to set all the values at one time. So suppose that I create an array here that has 10 elements. And so initially those are empty elements. I can then go ahead and say, hey, array, fill all your elements with the string X. And then as a result of that, I have my 10 elements and they all have that same value. And I can pass whatever I want inside that fill. So these are two common mutators that we have. One to be able to do a single write into our array, and one to be able to set all the values in the array. So let's talk about transforms. So if we wanted to take and convert our array data type into a string, there's a number of different ways, and we'll learn another an alternate way in the future as well. But there's a couple ways we can do this. We can use the join method, and so what the join method looks like is this. I have my array, and I just use an array literal expression right here. So this is an array that has 3 elements, 10, 20, 30, separated by commas. I can actually go ahead and invoke a method on any array that's called the join method. And inside the join method, I would pass a string that acts as the delimiter by which when it stringifies it, when it converts it to a string, how is it going to distinguish between each of the individual elements? So if I put a string that is an empty string, then it's going to just jam all the elements together, right? 10, 20, 30. If I pass it a string that has the comma, then it will insert a comma in between each element as it stringifies it. So this is a really useful function to be able to convert your arrays into strings. You could also use the toString method. That works as well. So if you have an array, again, same array, 10, 20, 30, and I go ahead and invoke toString, it'll do essentially exactly what the join did with the comma and with the string of a comma. It's just the join allows you to define different delimiters. And then you can also use the concatenation operator. So if you had an array and you concatenated it with a string, it would go ahead and invoke the toString method implicitly, much like Java does. So again, all these are pretty similar to what you probably expect these behaviors to be if you have a strong foundation in Java. The logic ends up resolving usually mostly the same. Let's talk about transforms the other way around, from strings into arrays. Well, if you have a string and you want to break it into an array, you can either use a split or a from function. So suppose I have this string, right, A, comma, B, comma, C, comma, D, and I wanted to split that on each comma. Then it will resolve by removing the commas and subdividing each of these strings as an array of substrings. So here I get an individual A, an individual B, an individual C, and an individual D, all as an ordered list, the 4 elements large. I can also use the array from method as well. So I can pass this string to array.from, calling it on the class name itself, capital array, and that will go ahead and you'll see on a string, it'll iterate through the string and convert that into an array. So those are just 2 ways that you can transform between various data types. These are usually really useful things to know as you start dealing with data structures. Okay, now suppose you need to transform between an array to another array. There is the splice method. So the splice method has a number of different parameters, so I kind of want to walk and step through this. So if we want to add items to the array by an index without deleting pre-existing items, then I can call splice. And so notice my splice has, typically splice has 3 different parameters. So here, this is the second line. So on my array, I call splice. The first parameter is what is the index I want to start at, I want to access. How many things do I want to delete from that index that are currently in the array? So I want to start at index 1, so that's at B. I don't want to delete anything in the array. So this parameter represents how many things should I delete out. And then the last parameter, I said it was 3 parameters, but I know this looks like 2, but this is actually, this could be a multi-value parameter. So anything that's left over are going to be the new values that are inserted into your array. So splicing allows us to add into a pre-existing array a new set of values specified at a particular index, and it allows you to overwrite into those indices if need be. So here we're going to start at index 1. We're not going to overwrite anything, and we're going to add 2 new values, 1 and 2. So we'll go ahead and send to the console log the new result of the array, and then we'll also show what actually got removed from the array. So removing things, typically when you remove something from any data structure, it gets returned out. So like if you pop something, if you unshift something, all these things, remove the element and then return it out. So we're going to see if anything gets returned out from this splice command. And so what we're going to notice is that our array now looks like A, and then index 1, we have the 1 and the 2. These are the 2 things that just got added in. And then afterwards, since we didn't opt to delete anything, it pushed back the B and the C. So now our array went from having these 3 elements to having these 5 elements. And we'll go ahead and evaluate the state of removed, and we'll see that removed does not, it's just an empty array. So nothing got removed. But notice we do have a value for remove. Something did get returned, but since we opted to do no deletes or removals, that is just an empty array. Okay, so let's look at another example of splice, just to make sure that we kind of understand what's happening here so we can see it used in a slightly different way. Let's say we want to add items to an array by a particular index, but we do want to delete items that might already be at that index. We don't want to grow our array in size. We just want to overwrite into it and keep it the same size or as small as possible. Then again, remember the params are 3 params for splice. The index we want to start writing into, how many elements we're willing to delete, and then the rest is the collection of items, and just as a comma separated list, it's like a rest parameter. It's a that we're going to add into this array. So here we start with the array ABC. We're going to invoke this splice, and so we're going to go at index 1, so where the B is at. We're going to say we want to remove 2 things. So the idea is that it'll likely remove the B and the C, and we're going to add in 2 things, which is everything else. We just happen to be adding in 2 things, which is going to be the 1 and the 2. So we should expect that the things that are removed are going to be the B and the C, and that the new array should be A, and then at index 1 should be 1, and then at index 2 will be 2. So let's go ahead, and if we console log this out, we'll see that the new state of the array is A, 1, and 2, and then what got removed here from this splice is going to be an array consisting of the elements B and C. Okay. It gets even more interesting. Splice can be used more than just inserting things, though. You can use splice to be able to process on an array just to remove elements. So let's say if we ignore the 3rd parameter, which are elements we want to go ahead and insert, and if we just look at using splice with the first 2 parameters, where I state what index I want to target and then how many elements I want to delete from that target. So suppose that I have this 5-element array. It has A, B, C, D, E. And on that array, I'll splice at index 2. I will then tell it to retrieve 2 elements from there. So this is index 0, that's A. This is index 1, this is B. So at index 2, at C, I want to remove that index and the one that follows. I want to remove 2 elements. So C and D should be removed. Now remember, whenever we call splice and we tell it to remove something, it actually returns an array that contains the elements that got removed. So we're going to inspect from the console.log both the state of the array and the state of the variable removed after this call. And you'll see, yep, we have A, B, and then E because C and D got removed. Interesting enough, we can do the same thing with Splice. Splice does support negative indexing. So if you've ever used a negative index in Python before, it works the same way. So even though we can't use negative indexes for indexing into an array, the method splice allows us to go ahead and traverse the array backwards. So if I pass in a negative number as the index, it's going to start counting from backwards to find the index. So this would be so at -2, notice it's going to go from -1, which would be E, to -2, which would be D. So it's going to target D here, and then it will remove 2 elements starting at D. So it should remove D and E. And in fact, after this call, if I were to evaluate the removed variable and the array method, you see the array method now only contains 3 elements, A, B, and C. And the removed variable has D and E. And again, this index means that the counting starts at the last element and moves forward. Now, the indexing starts at -1. So if I pass -1, that would actually represent E. -2 represents D. -3 would represent C, and so forth. So it's not like there's a -0. That doesn't, -0 can't happen like it can with positive, because there's no distinction from the computer, the difference between a -0 and a +0, like 0 to 0. Okay, we're done with Splice. I know that Splice can be relatively interesting. It's a really powerful method. It's definitely worth knowing. So I want to spend some time showing you all the different ways it can be used to process on arrays, to either append elements or actually insert elements, and to extract elements. So it'll be a powerful mechanism that you can use to mutate the state of your array. Let's talk about other things we can do though. Suppose you have 2 arrays that you want to merge, or even more than 2 arrays. So suppose that I had array 1, which has A, B, and C. Suppose I had array 2, which had D, E, and F, and then array 3, which had G and H. So I had 3 different arrays that combined have 8 different elements, and they're all different sizes. Then I can use the concatenate function or method on an array to go ahead and merge those together. And actually, there's another way that I could merge arrays too. I'll actually let me add that in here so I don't forget. I can actually use the spread operator. So let me put spread operator, and I'll show you this in a moment. Come on. Birth rate. Yeah, okay. I will actually open up the console so you can see what this will look like. I'm just making a note for myself so I can add this into this slide now. I was going to hold off on showing all spread operators, but I kind of want to show them when it's relevant. Okay, going back here. So the concat method has to be called on a array instance. So suppose that I have R1, which is this instance. It has the concat method, and I can pass in any number of arguments to this method. And although each of them has to be an array, what it's going to do is it's going to concatenate onto this array all of these arrays. So if this array was originally A, B, and C, I will then concatenate this array into that array, giving it D, E, and F. And since this can use a comma-separated list, I can also pass the other array, which contains G and H, and it all gets defined as a flat array. Notice I'm not adding these as as nested arrays, these are all individually available. So Concat's a very powerful way if you have two arrays where you can go ahead and merge them together. I'll show you how you can use the spread operator as well. This is probably the way that you would see it, in more of today's sensibilities than Concat, because in my opinion, it's a little bit more elegant. Let me open up a quick page just to show you this. Let me open up window. Let me go to about blank. Let me go to my dev tools. Just go into the console here. Okay, so suppose that I had a R1 that had, say, 1, 2, 3. Suppose that I had a R2 that had, I don't know, A, B, C. Suppose I want to merge those two. I can create a new array, and then I destructure the first array, which means I break it apart and I treat it as a set of individual elements. So 3 dots on any data structure destructures it. I'll go into more detail when we get to that section, but this is just a proof of concept. So I'll destructure both the first array and second array into another array, and you see if I hit equal, by destructuring them and inserting them into a new array, it'll go ahead and merge those two arrays together. So that's just an alternate way that you can merge arrays. And then another way we can process on arrays is going to be to slice up an array. So what does it mean to slice? Well, let's take a look at this. To get a subarray containing items, all we need is, at least initially, is a starting index. So suppose that I have my array. It has 5 elements, A, B, C, D, and E. And I go ahead and on my array, I slice it. I don't splice it. I slice it. So when I slice the array, I'm going to tell it to slice at index 2. So I give it the starting index, and I'm going to save the subarray, which is going to result from this function call, this method call. So the big thing about slicing versus splicing is splicing mutated the original array. Slicing does not affect the original array. It always creates a subarray. So if you need to make a distinction between changing an array, pre-existing array you already have, versus keeping the original array the same and only creating subarrays from it, that's going to be the difference between using a splice versus a slice. So here, starting index is at 2. So when I inspect my console.log at both my array function and my subarray function, you'll see that my array remains unchanged, right? It still has A, B, C, D, and E. But now the subarray I generated started at index 2, right? 0, 1, 2. It started there. And since I didn't give an ending index, I went all the way to the end. So now I get a subarray that's autonomous and different than the original array that contains the elements C, D, and E. Now suppose that I wanted to go ahead and only slice a particular segment that didn't include the beginning or didn't include the end. Then I can pass 2 parameters, where one is the starting index and the second is the ending index. So that's what I'm going to do here. I'm going to slice from index 1 to index 4. And you'll see, again, no matter how I slice it, it never affects my original array, right? It always has the same elements, but the subarray I generate, well, let's see, at index 1, 0, 1, I have my B, and then this is index 2, index 3, and then index 4. So notice that index 4 is where you cut off, right? It does not include index 4, right? That's 0, 1, 2, 3, 4. So I get back a result from B, C, and D. So always know that the index you get is not inclusive. It's an exclusive parameter as the second parameter. So that's the one that's at the index that you want to not have in the subarray. Okay, we talked a lot about arrays. They're really simple to use, but there's a lot of methods that are defined in them. So I know it would take a little bit of time for us to get through some of those auxiliary methods. Before I get into stacks and queues, does anyone have any questions about any of the topics I covered, just in terms of arrays? And they're really, in my opinion, more like lists than they are arrays. Or does this seem Is everyone with me so far? Does this? I know it'll take actually doing labs and homeworks to really get a grasp of this, but is there anything conceptual here that is that doesn't make sense or that seems confusing? No? Yeah, I very much enjoy how scripting languages handle both array and strings as well. And just being able to process on volumes of data. I like the I like how numbers are used as well. Being able to not have to recall the scope and size of my numbers whenever I do any kind of mathematical operation. Okay, so now that we've kind of comprehensively covered arrays, let's talk about stacks and queues. Now we can get stacks and queues. I'll define stacks and queues. That's the first thing we're going to do in this overview. But in terms of how we'll be able to get stack-like or queue-like behavior from our arrays are going to come from the methods of being able to push and pop or to shift and unshift. And so really the only difference between stacks and queues is the order of operations that things are removed from an array. So it depends on whether you want to go for something like first in, first out, or if you want first in, last out, or last in, first out. That ends up being the same in terms of a metaphor. So let's talk about stacks and queues. So a stack, as you probably learned already in data structure, which I'm pretty sure everyone has had. I think that's a prereq for this class. All a stack is, it's a linear data structure, just like a list or an array, which follows a particular order in which the operations are performed. The order can either be last in, first out, or it can be first in, last out. Either of those work for a stack. An example of a stack would be pancakes. Or plates, right? Like, so with pancakes, right, the first one that's put on your plate is always going to be the last one you're typically going to eat. You'll always typically eat the first one or the last one that was put onto your plate. Queues is a linear structure like an array or a list that follows also a particular order in which the operations are performed. The order is first in, first out. A good example of a queue would be like going to grocery store and having to wait in line. The first person to get in the line is going to be the first one who's going to get service. The last person in line will be the last one to get service. And obviously the difference between stacks and queues is in the removing. Like, things get inserted into them very similar, but it's determining the order in which you remove things from it, which is really going to give you that distinction. And so queues and stacks are used for different problem-solving domains. That's the only reason why I want to cover this. Sometimes it's very useful to throw items into an array, but remove them using a stack-like approach as opposed to a queue-like approach. I'll try to find some good coding challenges that kind of convey that. So let's talk about the tools we have to use if we want to model like stacks and queues inside of JavaScript. Well, all arrays have built-in methods called push. And so you'll see the parameter is v here. That means a value. Whenever you see, so a singular value is what that's implied. Let me give this some formatting to convey that this is source code. Well, actually, let me actually color code that too. There we go. That way we can see that, yeah, that is source code. Okay, so we have a pop and we have a push. So push inserts an item at the end of a list, and a pop removes and returns that item from the end of the list. So here, let's take a quick example. I'm going to create an array that has the elements A, B, and C. And then I'm going to say, hey, pop that. And it not only removes it from our array, but it's going to return that. So I can then save it. I can bind it to a variable. So I'll go ahead and do an assignment operation to item here. And then I'll just do a quick console log on what my array looks like after that pop, and then what the state of this item variable is. And you'll see that I now have two elements inside my array, just A and B. The last element, the thing that got popped off, is now the thing that's at item. So again, the concept of being able to pop things off, very reminiscent of what gives us that stack-like behavior we might be looking for. Now, let's look at push. So push allows us to insert an item to the end of the list. So I'm going to go ahead and take this X. I'll push this into my array, inspect the array, and now you'll see A, B, and X. So now, so really push and pop are just ways of removing and adding elements at the end of the list. But again, it allows us to go ahead and define some interesting behaviors there. Let's now look at shift and unshift. All shift and unshift are the same thing that push and pop are, but it affects the front of your list. So shift allows us to insert an item at the start of the list, whereas unshift allows us to remove and return an item from the start of the list. So let's create that same array again, A, B, and C, and then I'll tell it to shift out of this array the starting element, and then I will bind that to item here. So if I go ahead and just console log that, I'll now see that my array is indeed holding two elements, B and C. I'm now missing the A, and item, the variable, now has the value. It was also the value of A, the thing that got shifted out. And then if I want to go ahead and insert a new element into my array, and if I want to do it from the front instead of the back, I can use unshift, pass that value, inspect the array, and now I can see that element's right at the beginning. So the cool thing about having shift and unshift and push and pop is it allows me to define all sorts of interesting ways of having stacks and queues, whether I want to add things to the front or the back in order to get that behavior. So again, if I use unshift and shift, it gives me stack behavior from the start. If I use pop and push, it gives me a stack-like behavior from the end of the list. If I use unshift and pop, it gives me a queue-like behavior going the direction from the start of the list to the end of the list. And if I use shift and push, it gives me a queue-like behavior in the direction from the end of the list to the start. So you have lots of operations to be able to mix and match to be able to get queue-like and stack-like operations. And super simple. These methods are built right in. So if you're modeling something in your logic, I'm like, oh, I need stack-like performance, and for some reason I need to do it from the front end of the list. Bam, those are your options. Okay. Let's get into sets. So with sets, quick overview. I want to describe what a set is in JavaScript. I want to go over the methods, quick method overview that we'll have for sets. We'll talk about how to instantiate a set. When I say what are the properties of a set, I really mean what are its fields or its instance variables. I want to talk about how we can access data out of a set, how we can mutate the contents of a set. So fundamentally, in object-oriented programming, we call those our getters and setters. And then I just want to look at a couple of different ways we can transform on a set. Transform a set to a list and a list back to a set, or how to take a set and convert to a string, or take a string and convert to a set. Or let's see, I might not actually do this latter one yet. I think I might do that later on, because I don't think that set actually has any good methods for converting into strings. And that's the same with maps, and that's the same with objects as well. So we'll talk about how we can take more complex data structures and start translating them as a string representation, which will be super important for us in web applications. Being able to represent your data, to serialize your data, is going to be something we'll talk about, but it'll be something we'll talk about in the future, not with just raw JavaScript in the form of data structures. Not needed yet. So let's talk about what a set is in JavaScript. Well, a set is a keyed collection where each item in the list in the collection is unique. So here, sets really distinguish themselves from maps, where they don't where the key and the value are the same thing. So all a set typically is it's usually considered a list where every element is unique. Now, a big distinction between a set and an array or a list is an array or list is ordered, which means that you can use an indexer to access the first element all the way to the last element. But since sets are not technically ordered, there's no concept of index number. So and same with a map or a associative array, where you can have a indexer that could be some other data besides an integer number. It could be a string, or it could be whatever value you might assign to it. There's no real way of grabbing a particular data value from the set. So that's the big distinction here, is sets are not associative arrays. They're not indexed arrays, right? They are a collection of elements where there is a guarantee that they are all unique. And so that's going to be really interesting for our getters, and that we'll see in just a moment. So sets are objects, yeah, just like arrays are objects, which means they have their own predefined methods on how we can traverse them and be able to set and get the values within them. So if I do a type of on a set, we'll see, yeah, a set is an object. So let's see, sets, the types of elements is not fixed. And this is, again, true for any data structure in JavaScript, but I'll keep highlighting that as we keep going through all of these data structures. Again, JavaScript is not a strongly typed language. It's a loosely typed language, which means we can mix and match our data types however we want. So I can have a set that holds strings and numbers and booleans and even complex data types like objects. And that's perfectly valid and fine. Sets are guaranteed to be dense. So whereas our array, since it uses the index number to go ahead and provide an ordering to the contents of the array, remember I said that sets don't have an ordering and that every element's guaranteed to be unique. So if I created a new array that had 100 elements, I'm passing that integer. So remember that creates a 100 element array where essentially they're all empty. And then I use this array inside the constructor of a set. And again, we'll see that when we get to the initializer. So I'm nesting the instantiation of an array, a 100 element array, to build that into a set. And I'm going to save that set as just a term that I'll call keys, because that's usually a common thing that you could call a set. It usually represents a collection of keys, because keys are usually unique, or you call it IDs if you want. I think keys is more common, though. The result of this will be a set that only has one element, which is undefined. So where the array had 100 undefined elements, because the order matters there, everything is unique. And since every element inside of our array was an undefined element, object, an undefined object, it only has the one. But also keep in mind that when we create this array, it actually holds objects. Like those objects are just undefined. They're singleton objects of undefined. So they're all referencing the same undefined object, but they're constant. There's actually a reference at each one of those cells that can then be overridden. Okay, let's look at a different example, one that's not just an empty array that's huge. Let's suppose that we had this array that had several, I want to say, what is this? 7, 1, 2, 3, 4, 5, 6, 7 ones. And I'm going to go ahead and build a new set from this collection. And I'll bind that to a variable called keys. We'll see that my set here is just one element large. Again, because it guarantees. So sets are guaranteed to be dense. And actually, let me add a new condition in here that I think is worth mentioning. And it also guarantees that each item is unique. And that's also why it's not dense, right? The only thing it maintains are unique items. And it doesn't have an order. So quick overview of the methods that we'll be looking at today. Constructors. So sets have a constructor called set. We'll look at the ability to access data out of a set. So those are going to be the size. And actually, let me do this to illustrate. So has is going to go based off of a value. Clear, add a value, delete by value. I want to distinguish right now, while I'm making these slides, the difference between methods and fields, because we have to use a field to access the size of our set, but everything else that we interface with our set are going to be method calls. So I want to distinguish that right here and now. And so again, just like in Java, this is actually similar. If you recall, arrays have maintained their own size using a length attribute. And in fact, things like sets and lists and other things that can change over time use the size name. And so the naming conventions for arrays and the naming conventions for sets and maps come directly as they would from Java. So even though an array has a mutable size, it's still called a length, and a set and a map have size attributes. They don't have length attributes. Just give me a moment. Since I'm here, I'm going to quickly just toggle these over. There we go. Okay, so let's take a look at these. So instantiation. I can instantiate a set using a constructor. And again, constructors are invoked in JavaScript the same way they would be invoked in Java. So I use the new keyword and then whatever the constructor is. And if I use the default constructor, which is no parameters, then I just create an empty set. Or I can choose to go ahead and provide a parameter. And so the one restriction you have on when constructing a set is that the data type of the parameter has to be something that is iterable, something that can be subdivided and converted into a set. So that could be an array. You can iterate over an array. That could be a string, because actually each individual character in a string is actually iterable in JavaScript. It can't be a comma-separated list without being inside of an array, though. So if I just did like 1, 2, 3, 4 as commas, that wouldn't work. So the actual object passed in as a parameter has to be some container object, and it's got to be a container object that has the concept of being able to iterate across it. So I'll give you 2 examples here. And one of the nice things about JavaScript is if you're ever confused about any of this stuff, you could see, you just open up the interpreter and see if it works or not. And I'll give you an example for that in just a moment. So suppose I wanted to create a set based off of the contents of an array, 1, 2, 1, 2, 1. I can just pass in that array, tell it to build a set, and there I go. I have a 2-element set. Since it's guaranteed that every element's unique, it's only going to have the items of 1 and 2. Suppose here that I want to create a new set off of this string, which is 1, 2, 1, 2, 1. Again, what it'll do is it'll iterate over each of the characters and then treat that as the contents of the set. Now, suppose that I want to do this. Okay, so do I still have that? No. So let me open up. So I'll show you one beautiful thing about interpreted languages, especially one that's really super available to you right in your browser, is that at any time, you're like, can I do this particular method? Oh, also, let me say that if you use Chrome, and I'm sure other browsers do this as well, it'll also autocomplete on you. So what does that mean? Okay. So first, let me do that. Let me show you some cool things you can do in here. So suppose I do keys, and I'm like, oh, I want keys to have a new set, right? Now notice as I type, it gives me options. It's trying to base, just like a full-featured IDE would, it's going to try to predict what could this statement resolve to be. So I'm gonna resolve it myself. I'm gonna say, oh, I'm just gonna create a new empty set here, but then again, I can expect it, and then I can unpack it here and see all my entries and the size, and it's really cool. Like being able to explore the state of your data at any given time right in the console window, super powerful for debugging purposes. Now, suppose that I want to see what methods are available for me on a set, and I don't want to bother looking up the API because I don't know, I'm lazy. I can do period because we know periods are the special operator that allows us to access the internal contents like methods and variables that are declared in some kind of outer container like a class or an instance. And so if I do that, autocomplete is going to work as well. So I can see, oh, my set has the ability to have an add method, a clear method, it's got a constructor, it's got a delete, entries for each, has, keys. So if at any time you want to see what does any particular thing, what can any particular thing do while you're coding for client side, just open up your console and instantiate it and check it. Just do a dot and let it autocomplete, and you can kind of go through it. And if you do a I probably don't want to do that, but so I could like add, and then if I start to open it up, it'll even tell me what it expects to go into that function. So it expects a value. Another example, so like window here, if I type in window, that's like my global object. I can unpack that and see everything inside my window. So again, really, really powerful tools that we have built right into the browser that you don't have to install at all. Just by, well, you do, you just have to have the browser installed. But yeah, I think the point of this was.
What?
So I want to show that if I tried to make a set with just a comma separated list, that won't work.
Oh my God.
Uh-oh, someone's mic. Okay, hang on just a moment.
You ruined the code. Oh my God.
Okay. Okay, so the entire point of this example was to show, though, if I go ahead and try to do this, that it's going to fail. I can't just pass in a comma separated list here, 1, 2, 3. But if I tried, if I wanted to check if I could do that, like I don't have to memorize all the rules. I can always just open up my console and try to do things. So that's what I'm going to advocate that you do. Like one of the greatest things about interpreted languages is they're like playgrounds where you can explore your data at any time, poke it, you can prod it, you can inspect it, you can attempt to do things. And if you can't, it'll give you an error message. It says right here, number 1 is not iterable. So now I know, oh, there's a rule. If I want to go ahead and do this properly, it's got to be something iterable. So I can't just give it a comma separated list. I have to give it an array that contains the comma separated list. And then suddenly, oh yeah, that works. So again, I know that learning a new language always is a commitment. Fortunately for us, JavaScript is very similar to Java, and the parts that don't, you can always just explore right in the console and try what you think might work. And if it doesn't, read the error message and then see if you can't fix it. Okay, I'm done with instantiation on sets. So the next thing I want to talk about is to go ahead and talk about the properties. So unlike arrays that call the size of or the number of elements contained within it length, sets use size. So size is different than length, though. I will say that the different name does imply some different characteristics. So the size of a set is not fixed, just like a length. It can grow and shrink based off of adding and removing items. But where size varies from length, and this is funny because it's actually the inverse of how you might think of it in Java, is that with size, you cannot reassign it. So like earlier, we saw how we could actually reassign the length of an array. And I'll show you really quick. Since I have my console open, I can create, let's call this a array, and let's make it empty, right? And so if I look at array dot length, right, it's 0. I could say, oh, I want that to be like 1,000, right? And so now if I look at array, look, all of a sudden I have 1,000 elements in there. And I'm like, oh no, I don't want it to be. I want it to be actually 0. Okay. And if I inspect it, it's going to be empty. So we can actually mutate what is held in the array by actually overriding the length. I can't do that with a size variable. So both sets and maps use size variables. I can reassign it, but it ignores this. It does not affect the actual element representation like it does with arrays. So just to highlight this, imagine if I create a new set off of this array list initializer. So 1, 2, 1, 2, 1. So it's going to be 2 element set, and that's exactly what it says here, 2 elements, as it's showing me the size. And then I'm going to say, okay, take and overwrite the size of that set to 0. And actually, it prints out 0. So it seems like it did the same thing with the array's length. But then if I go ahead and look at my my set, it's going to say there's still 2 elements there. And in fact, if I inspect the size there, it'll still say it's 2. So it actually ignores us trying to override it. So there's actually another mechanism if you want to clear the contents of a set, or if you want to clear the contents of a map, than you would with an array. An array, you could actually just overwrite the length. That's super dangerous, though. It's not probably the mechanism you want. So we'll see how we can actually mutate the state in the next couple of slides. So let's talk about our getters. How can we get data out? Now, like I said, it's not like a map where you have like technically keys. I call these keys. These should really be called values, right? Because keys kind of imply that they're associated with something, that they unlock something, which these don't, right? The keys and the values are the same thing. So there's no way to actually extract individual items directly out. So it might prompt you to question, well, how do you access values from a set? Especially since sets are not ordered and there's nothing to index an individual item to a set. And so the idea is that you have a has method and you pass in a value. And really what you're looking for is you just want to know if something is in a set or not, right? So the idea is that if the set always contains a unique thing, then the only information you typically want to get back from a set is if it contains a thing or if it doesn't. And that's exactly what the has method does. So you pass it in a value, and then it'll tell you yes or no, true or false, if your set has that value or not. So an example of this here would be, imagine if you had a set, and I'm going to use this common array I've been using, which will be a 2-element set. And so I'll then ask, do you have 1? And it'll say, yes, yeah, I have that in my set. Then I can ask it, do you have 4? And it'll say, no, I don't have that in my set. So it allows you to make evaluations and track things and use that for whatever kind of logic you need that you're governing off of using your sets. So then let's talk about, now that we know how to access things by sets and really it's just asking if it contains something or not, let's talk about how we can set something into a set or mutate something in a set. So we can either add a item to a set, we could remove an item from a set, or we can clear a set of all of its elements. So if we wanted to go ahead and if we wanted to add an individual item to a set, so let's create just an empty set, we just use the add method and we pass it an element, right? And we'll add that into the set. Now, can we add more than one element? Well, that's a good question. Let's find out. Again, clear this. So it's, let's see, let's call this vals is equal to new set. Let's say, so let's start with the 1, vals, and we're going to add just that one element. So we'll add in an A. Okay, so so that worked. Now the question is, do you suppose we can add in more than one value? Well, I could go read the API, right? But if I have a question like this, I could just try it. Let's say I want to do that, and there we go. I go and do an add, and so it added it, so it did not fail. But look at the condition of my set. This is probably not what I anticipated, right? So now I know that I can pass in any number of parameters I want into the add method, but it's actually only looking for one value. So we'll ignore whatever values are after the first. And so I was able to successfully add an element, but not get the behavior that maybe I anticipated. But does this make sense? Do you see how you can kind of play around if you ever have a question to kind of see if your suspicion on how something might work actually works within the interpreter? Again, just a powerful one of the powerful components about interpreted languages is that they're a playground. Okay, wait, where did I feel like sets, getters? Oh yeah, I was on here. Okay, so that's how I can add an element to the set. Now suppose I want to delete something from my set. Well, it just has a delete method, and I pass it the value that I want to delete. If it's not there, then it will resolve as false that that item did not get deleted. If it is in there, it will return back a value of true to say, yes, I successfully found that item and deleted it. So in this instance, I invoked the delete method, and I went ahead and actually passed a value that was within the set. So it's a true, it successfully deleted it. And if I inspected the items after that, it then shows that I have removed that item from the set. So I only have a set that has 1 and 3 now. And suppose that I have a set that I need to refresh out before putting new elements in for some reason. Well, there's a clear method. This is a way safer way of clearing out a data structure than just resetting the length to 0. Now, don't get me wrong, that works. Setting the length to 0 does empty things out, but there's something nice about just having a clear method that does that for you. So here, if I have my items, I clear it, then suddenly my set is 0. And then finally, in regards to sets, I just want to talk about how we might be able to convert between or transform between sets and lists, simply because often is the times that there'll be functions and lists that are not available to sets. Both sets and maps have methods that are kind of exclusively for traversing and operating on them, but it's pretty common that there's a much larger collection of powerful processing methods inside lists, which I'm going to cover at the tail end of the PowerPoint slides tomorrow when I do the second half of the data structures lecture, that we might want to take advantage of. That's the big reason why I made sure to put into these slides how we transform between different data types. So it's my impression that I'm talking about these things so that you have access to this as a reference document. So you can look at my slides and, if necessary, rewatch these videos to get my explanations. And so here, being able to convert to a set to a list, we've already seen that. Like if I have a list, or to convert from a list to a set, we've already seen that. We do that with the set constructor. So if I have a list, I pass that list in as my parameter inside of the set constructor, and I convert that list into a set. So we've seen how to do that. Now, what we haven't seen yet is like the opposite of that. How do I take my set and convert it back into a list in case I want to get like one of the like dozen of powerful methods that we're going to talk about tomorrow? Well, one way is Array actually has a method that's called from. I think we saw this before using a string, right? We can actually pass in any iterable object. Well, sets happen to be iterable objects. So I can go ahead and also use the array.from and pass in my set. So here's an example that I'll create a set. I actually create a set using a string so that I get a set of 1, 2, 3. But then I'll go ahead and then pass the set into the array.from method, and you'll see it converts it into a list or an array. And just like I showed you last time, I think in the arrays area for concatenate to be able to merge, I can also use the spread operator to destructure all the elements of a set into just a collection of elements, and then I can put that into the list initializer to convert that into a list. So we're really this spread operator, when it got added into the JavaScript language back in like ECMA 5, has been a very, very powerful tool for destructuring complex data structures. And we can use this on sets, we can use this on maps, we can use this on objects, and we can use this on lists. It's going to be a very powerful tool. So it's going to be very well worth learning how to use this in two different ways, actually. It works differently as parameters and functions versus how it's used on data structures. And so at the tail end of the PowerPoints tomorrow, we'll actually see how it's implemented or represented in two different ways. Okay, and so that leaves us off with sets. So I think I had gauged my time relatively well with what I wanted to talk about today, and kind of talk about the data structures things maybe a little bit slower than I did the basics, so that I could really like harp in on some of the differences between these. So next lecture, I'm going to finish off this PowerPoint slides. What we'll do is we'll pick up where we left off. So that will be to cover maps, which are essentially key value pairs. They could also be called dictionaries. We'll look at iterator functions that can be applied on arrays, sets, or maps. We'll look at all of the various traversal methods, the powerful processing methods. Let me call this traversal. I don't know. A traversal makes sense for that on arrays. And then we'll look at the spread operator and destructuring. And after that, if there's still time on Thursday, we'll then start to get into object-oriented programming, JavaScript. So with that said, is there any questions about today's lecture? How is everyone feeling in terms of the way that data structures are handled in JavaScript? Just looking at arrays, stacks, queues, and sets. One nice thing is they're all built in. There's nothing we had to import, right? Like if you need to use any of these tools, they're imported as all part of like the standard libraries where you can use them just from the get-go. Okay, perfect. Yeah, that's the thing. So a lot of, fortunately, because we've learned a lot of Java, a lot of what you've already learned for Java, we can apply conceptually to JavaScript. And that's going to continue to be the case when we learn dictionaries, as we learn the iterator functions. Actually, the iterator functions are in the Lambda functions that are available in JavaScript are actually available in Java. I just don't think that they're covered in the lesson plans and the intro lectures. And then when we get into classes, the way that we structure classes and inheritance is all going to be exactly the same. So there's just going to be these little nuanced differences, but for the most part, like you might not realize it, but you already know how to do like 90 or 95% of JavaScript just from coming with a Java background. Excellent. Well, if there's no other questions, that's our lecture for today. It's my intent to. So what I'm going to likely do is I'll finish up. I want to do a quick refactoring of what my lesson is going to cover on Thursday, and then it's my intent to get some quizzes and some homework related to JavaScript out so that everyone can start practicing on that. Because I know that just talking about this is not going to do what it needs to do to get you to where you can start building applications. So I'm going to do a combination of either labs and quizzes, or quizzes and homework, or labs and homework. One of those, two of those three will be selected, either labs and quizzes, labs and homework, quizzes or homework. So I'll start working on that as well. Anyway, other than that, everyone have a great day, and I'll see everyone on Thursday. And if you have any issues on your current homework, that's the Bootstrap homework, please hit me up on Discord. Stop recording.